Welcome to our webinar. We are talking today about climate change. It's a webinar in our Environmental Matters webinar series. If you're interested in attending any Environmental Matters webinar series webinars, you can visit our website at www.ci.superior.wi.us/webinar. For every webinar that you attend, if you're a City of Superior resident, you will receive one entry into a drawing for a compost bin. So the more you attend, the more chances you have to win. Just a few things about our upcoming webinars. We have Getting Rid of Mercury on October 8th. We have the St. Louis River Alliance talking about protecting local waters on October 22nd. On November 12th, we have a webinar about the wastewater treatment plant process, how we treat wastewater here in Superior. And then that date is wrong. That's not 11/12. It should be 11/26. We will be talking about the different things that we do here at the City of Superior Environmental Services Division with regards to environmental education. So you can tune in for any of those, and all of those will gain you an entry into the drawing. So today's webinar, as I said, is about climate change. It's presented by Hilarie Sorensen. She's a climate change extension educator with the Minnesota Sea Grant program. So I'm going to pass it over to Hilarie, and she can tell you more about Minnesota Sea Grant and about climate change.
Hi everyone, thank you for being on today. I am Hilarie Sorensen and I work for Minnesota Sea Grant, and I'll do a little bit of an introduction about what Sea Grant is in just a minute. We will be talking about climate change today, and I do want to talk about it on a local level. What does it mean for our Lake Superior communities? But just to set up a little bit of a frame for the type of issues we're dealing with, I'll talk about it a little bit on a larger scale first. So America's health, security, economic, and environmental well-being are all really closely tied to climate and weather. Now, in the past 2 years alone, the United States has experienced 25 climate and weather-related disasters, exceeding over $1 billion in damages and claiming over 1 million lives. So that's a huge, huge number there. Now, communities at all levels, and businesses, resource managers, and policy leaders are becoming increasingly interested in gaining information to help understand and prepare for how and why climate conditions are changing and how we can increase our community preparedness. So that's a little bit of just the global context of what we're talking about. Now we'll bring it a little bit local to talk about Lake Superior communities specifically. So what we're going to be talking about today, I'll go through a little bit of what is Minnesota Sea Grant, talk about climate change. I mean, we could talk about climate change for weeks and weeks and years, but we'll just provide a little bit of a snapshot today about how scientists predict climate change trends. Talk a little bit about local impacts and adaptation strategies, and then I'll talk about a tool that, a couple of tools that communities are beginning to use to move forward with this planning process. So, part of Minnesota Sea Grant is part of a national program that receives funding and support from the National Oceanic and Atmospheric Administration's Office of Oceanic and Atmospheric Research and the University of Minnesota. So it's a federal-state partnership. There are 33 similar Sea Grant programs in the United States and Puerto Rico. One of the main jobs that Sea Grant extension agents do is to work with coastal communities through scientific research and education to enhance coastal environments and economies. So we work with partners on local, regional, and national levels to engage coastal communities along Lake Superior and inland waterways to identify needs and provide information, resources, and support for some environmental initiatives that are taking place. So climate change fits into Minnesota Sea Grant's mission through its focus on how climate change may impact Lake Superior and the aquatic resources in the area, as well as the folks who rely on these resources. So how does it impact our economy and these ecosystem services, more of the social side of climate change impacts as well. So we work on climate change issues through education programs, looking at the expected impacts and how communities can respond to, prepare for, and reduce the impacts from a changing climate. So before we really get into the nitty-gritty details here, the first thing I want to talk about is the difference between climate and weather. Pretty simple, but when we're talking about climate change, we're really talking about trends over time. So that's the important takeaway message with this. So weather is the state of the atmosphere at any given time and place, looking at temperature, humidity, precipitation, cloudiness, wind, etc. And then climate is the set of meteorological conditions that prevail in a particular place or region over a long period of time. So we're keeping in mind these long-term trends when we're talking about climate. I do want to show just a really brief video next, if it works, that I use with a lot of different groups, and people seem to really like it. It's very, very clearly illustrates the difference between trend and variation. So I'll show that here. It's just about a minute long, and then we'll continue on.
A common mistake when interpreting statistics is to look at them from too short a distance. This can make everything unclear and confusing. So forget the details and take a step back. You're looking at the dog when you should be concentrating on the owner. As you can see, the dog is all over the place, leaping and bouncing, sometimes upwards, sometimes downwards. But where do you think it'll be in 10 seconds' time? Around here, right? But at this moment, the dog is on its way downwards. So why do you think it'll find itself up there? It's because you noticed the owner. The owner is the trend, and it's here we determine where they both will be in a while. It's a bit longer than a couple of dog bounds. He could change direction. There's a lot we don't know about this guy. But everything we do know indicates he's heading in that direction. The owner is the long-term trend. The dog is the variation around this trend. Or the owner is the climate. The dog is the weather.
So I don't know if you guys all got that, but that's from a Norwegian broadcasting company. And really just, I love that video and the way it illustrates that we deal with a lot of variation in our area. And a lot of uncertainty. There's a lot of uncertainty when we talk about climate change, especially when we try to talk about it on a more regional or local scale. So now I'll talk a little bit about how do scientists determine trends? How do we even begin to predict how the climate is going to change? I'm sure you all have experience with the difficulty in just seeing what the weather is going to be like soon. So I'll talk about a few different ways that, that scientists look at this. So the first one is through observation. Talk a little bit about observation. We're seeing things in our area that we're not used to typically seeing, and then some other things that we associate with Minnesota and Wisconsin and the Midwest are changing in our area. So an example of this is the moose population not doing very well in Minnesota, where we seem to be having a longer growing season by several weeks. There's a little bit of concern about invasive species and impacts on our changing forest ecosystems, as well as severe events like flooding and drought that we've seen in recent years in this area. So observation is the first key. Scientists also determine trends through data collection and modeling. So the better data we collect through monitoring programs, the better predictions we can make. So these modeling techniques require actual measured data to determine the relationships between variables such as temperature, precipitation, carbon dioxide emissions, and clouds, oceans, topography, etc. So the relationships between variables is looked at to predict trends or patterns that we might expect to see into the future. Now, one key thing with a lot of climate models are currently done on a global scale, looking at the past so that we can look to the future. Now scientists are trying to get a little bit better, refined techniques of how to bring these models into a smaller scale. So bringing them into a more regional level so that we can better predict what's going to happen in a particular location. So think of this slide as a kind of a visual weighted downscale. So global climate change models don't have the resolution to handle things such as mountains, valleys, and lakes that have an impact on local and regional climates. So global climate projections have to be adapted statistically to account for the presence of these features on a local level. So more and more work is being done to downscale these climate models and to make them as accurate as possible. However, many of the impacts in this presentation that we're going to discuss are still based on a global scale. So looking at some of these regional models, here are some of the range of predictions that's being made. So this is for the Great Lakes region. We're going to be looking at 2 climate change models, and you will notice quite a bit of variation in what temperatures the models are predicting. So there we come back to that variability and that uncertainty to keep in mind throughout this presentation. The top picture is what is currently being observed in temperature increase in the Great Lakes region, and the 2 bottom pictures are what is projected out to the year 2100. So using climate models, scientists project that average surface temperatures are likely to rise approximately another 5 degrees according to the Hadley model on the right, and 10 degrees according to the Canadian model on the left. And this is by the year 2100. It's interesting to note with this slide that seasonally, winter minimum temperatures will increase more dramatically than annual increase expectations. So the 2 models here indicate that the northern part of the Midwest will expect the largest increase in winter temperatures. The higher winter low temperatures of the Canadian model suggest the greatest increases in Minnesota and Michigan's Upper Peninsula. So on average, precipitation over the 20th century has been increasing. Now, the Hadley model indicates that the trend will continue to increase, resulting in an average annual increase of 25% from the present. So this increase in temperature means the air is warmer, warmer air can hold more water, and this is really important when considering extreme storm events. That's something that climate change really tends to exacerbate, are the frequency and severity of these extreme weather events. Here's another really local example taken from the Wisconsin Initiative on Climate Change Impacts, or WICI. This study was established in the fall of 2007 and assesses and anticipates climate change impacts on specific Wisconsin natural resources, ecosystems, and regions. And it takes that information and evaluates potential effects on industry, agriculture, tourism, and other human activities, and then recommends adaptation strategies that can be implemented by businesses, farmers, public health officials, municipalities, resource managers, and other stakeholders. So this was done in partnership with the University of Wisconsin, the Wisconsin Department of Natural Resources, and other state agencies and institutions, and is really a great example of how we're trying to look at this very large, complex issue on a local scale to help our coastal communities deal with these impacts. So here's kind of a summary of some of this modeling that I've been talking about, this climate change modeling. This is projecting out to the year 2100. This was a study conducted by the Union of Concerned Scientists. 2 mid-range emissions, CO2 emission scenarios were used to create this report. The data was combined with 100 years of historical climate data and gathered from 300 stations in the Great Lakes region to ensure that the global model output was calibrated by the regional historical record. So again, in the future, it is hopeful that regional climate modeling and other statistical downscaling methods will improve, but until that happens, we work with this type of data. So these temperature changes that are predicted will produce more heat waves and a growing season that's longer by several weeks. So this means that Minnesota is predicted to be more like Wisconsin in the winter and Kansas in the summer. Or this is the Wisconsin one, yeah. So a little bit more like Kansas in the summer. This model predicts that average precipitation may not change much, but the takeaway message is that there will be seasonal shifts with increasing amounts of precipitation in the winter and spring and possible decreasing amounts in the summer. We're also looking at a probability of more extreme events, storms and flooding, such as we've seen in the last few years, with a lot more frequency, as well as higher fluctuations in our Great Lakes water levels and reduced ice cover over those winter months. So for Lake Superior specifically, Lake Superior is actually one of the fastest warming lakes in the world. Superior and the surrounding coastal communities are experiencing changes in the amount of snow melt that we're seeing over those winter months, reduced ice cover and rain affecting Lake Superior and inland lake water levels. There has been increased stormwater runoff and sedimentation of rivers, streams, and bays during flooding seen in many Lake Superior communities in 2012. Water level fluctuation also has impacts for shoreline management, ecosystem health protection, shipping, recreation, and tourism activities, and increased extreme weather events have a lot of impacts for human health as well and well-being, as well as economic impacts on our infrastructure and water resources. So we're already starting to see a lot of changes in this area that coastal communities are starting to address. So these listed categories are where we're typically seeing some changes starting now and where we predict to see more changes into the future. So for the purpose of this presentation, again, we could focus on any one of these for a very long time, but I'm going to focus mostly on our water resources and changing precipitation patterns, looking at severe storms and droughts and how those impact our communities. One other thing to keep in mind throughout this discussion is that we really have a lot of cascading impacts. So climate change is not an issue that stands alone. Climate change really tends to exacerbate environmental issues that we already have in water quality and ecosystem health and infrastructure, longevity, all of these things. Climate change doesn't cause them necessarily, but it definitely creates stress on our systems. Okay, so to talk a little bit more about Lake Superior. The surface water in Lake Superior is warming twice as fast as the air temperatures. So when this is taken into account with reduced ice cover over the same period, there is increased evaporation contributing to lower lake levels. And this really has severe impacts for shipping, recreation, coastal development, all of these things. Lake Superior water levels, or Great Lakes water levels, are always in a constant state of flux. So the Great Lake water levels have varied considerably over the past several hundred years. As you can see from this graph, over the last 150 years, Lake Superior alone has fluctuated about 2.5 feet. So there is, again, a lot of variability when looking at lake levels, year-to-year variability, but the average estimation now is that lake levels will continue to decline. So these two graphs are looking at all of the Great Lakes, not just Superior. Higher temperatures do cause more evaporation, which will likely result in lower lake levels, that coupled with reduced ice cover. However, despite the best efforts, lake levels do remain highly unpredictable, unlike when we always hear about global sea level rise. In our Great Lakes, we do expect to see continued variability. So there are many possible scenarios that need to be considered when planning for lake level change. The black line on the graph to the left does show a clear decrease in the extent of ice cover since the 1970s, although again there are large year-to-year variations. This is a really localized example that was done by a student up on, for the National Park Service. This is showing ice decline. This is on the ice road from Madeline Island to Bayfield. And it predicts the duration of ice cover has declined about 3.4 days per decade since 1857 and 14.7 days per decade since 1975. So that's quite a drastic change that we've seen in that very localized area. Here's some more trends that are taken from historical data. These next few slides are courtesy of Mark Seeley, state climatologist with the University of Minnesota. This is Duluth, Minnesota's annual precipitation patterns that are recalculated every 10 years and based on the previous 30 years of data. So the normals, as you can see, are trending upward, and we can see approximately a 5% increase since the 1941 to 1970 period in annual precipitation. This is showing Two Harbors' increase of about 9% from the 1941-1970 period. And here's kind of a summary from some of our coastal communities looking at these changes in observed 2-inch rainfalls. So a 2-year or 24-hour rain event, as we frame it, that is expected to have a reoccurrence once every 2 years based on modeling and monitoring data from historic data. So in a 20-year period, there should be about 10 occurrences of these storms, or that's what we would predict. But as you can see from the data here, our local communities are actually experiencing 2-year events at least once a year or even more. So we're really exceeding these predictions of how many of these extreme rainfall events we're going to have. So we need to take that into account in our planning activities. So that kind of comes up in our new rainfall atlas, looking at the 100-year or 24-hour rainfall event. Previous data was based on TP40, and this, as you can see, TP40 is the old rainfall data, Atlas 14 is the newly revised, and then you'll see the percent increase on the right there. So this is really looking at planning for the future, building infrastructure today that in our communities that will be able to absorb the impacts from a changing climate that we're expecting to see into the future. So looking at the lifetime of our infrastructure and what kind of precipitation events that infrastructure is going to be able to handle. So again, this is important because of the wide variation of extremes that we have in our area. You know, it is highly variable, it is highly unpredictable, so being prepared for all sorts of different events. This is really clearly illustrated by this slide, again from Mark Seeley. This kind of demonstrates that variability that can happen at the same time. So in August 2007, several Minnesota counties experienced drought conditions, while at the same time neighboring counties were experiencing flooding. So drought and flood conditions happening simultaneously really point to the need for states to develop response plans for a variety of extreme weather events that may be occurring at the same time. Here's just a good image of some drought and fires that happened in the Cavity Lake burn, or Cavity Lake. So this really sets the stage for kind of what we were looking at before we saw our flooding last year in 2012. In May of 2012, we were actually concerned about drought and fires associated with strong winds. And then the rains came by Memorial Day, soils were quite saturated, which really paved the way for that June 19 through 20 extreme storm event. So again, looking at very rapidly changing conditions in our communities and how we prepare for those. These are a couple of images taken from streams up the North Shore. You can see drought conditions have severe impacts for our native fish populations. We have a lot of designated trout streams in our area, and with these drought conditions, the fish are unable to move from pool to pool and get out into the lake. So this has impacts not only on our ecosystems and our native fish populations, but on recreation, on our ecosystem uses of these natural resources. And then on the other extreme, we've got flooding. We've got extreme rainfall events and flooding. So in the United States, extreme weather events have made up a very disproportionate share of the observed increases in total precipitation. For example, the number of days with precipitation greater than 2 inches has increased. So increases in these precipitation accumulations has been greatest in the Great Lakes, Southwest, and Midwest regions of the United States. So extreme precipitation creates risk for flooding, erosion, water quality deterioration due to entrainment of pollutants and sewer overflow, and human health concerns associated with waterborne diseases, especially in more rural areas. So more extreme precipitation events also require more resources from local and state governments to deal with these things. So deal with flood cleanup, increased maintenance costs, and increased water treatment costs. So quite a large spectrum of impacts from these changing precipitation patterns. Here are some images from the June 2012 event, extreme storm event. And then I'm sure many of you have seen these images as well. This is taken after that extreme rainfall event in the harbor. Over an extra 100,000 tons of sediment was deposited in the harbor in 3 days, which is about equal to a year's worth of sediment, as well as blue-green algae was observed in Lake Superior after that flooding event. So severe impacts that last for quite a long time as well. So I'd like to emphasize that climate change is long-term, and that it's important to look at both our gray and green infrastructure to help make our communities more resilient to the impacts from climate change in our area. So no longer is a 100-year storm event valid for planning alone. So it's important to start this conversation within communities with a lot of different stakeholder groups early, and to increase collaboration and information sharing between educators and researchers, decision makers, communities, scientists, etc., to move forward in a collective way. So another thing to consider when we're talking about climate change are the more social aspect of things, our sense of place. Up in the Wisconsin, Minnesota area, we really do associate with winter a lot. So what does that mean for future generations if our winters change? So now that's enough of the gloom and doom. Now let's talk a little bit more about this so what question. So what can communities do to start to talk about these impacts and prepare for them and lessen the impacts that we're seeing in our areas? So a couple of terms that we hear a lot when we're talking about climate change are mitigation and adaptation. And it's really important to note the difference in meaning between these two terms. So an analogy that I like to use is mitigation is the brakes, putting the brakes on impacts, or an action taken to reduce climate change at its cause. Examples of this are reducing our greenhouse gas emissions in the transportation or food processing sector. While adaptation, I like to think of as the airbags of a car. So refers to taking steps to become more resilient or less vulnerable to the changes that we are already beginning to see in our areas and that we expect to continue into the future. So the adaptation also takes into account the great deal of uncertainty about when and how exactly our climate will change. So for the purposes of this talk and a lot of work that Minnesota Sea Grant is involved with, it has to deal with adaptation for preparing local communities, providing the tools and information for communities to start to address these issues. So another important point that I like to go over is that planning for changing climate does not need to be a completely separate process, but can be incorporated into existing planning processes. For instance, if a community is updating their land use plan or emergency management plan, there's a lot being done with education and incorporating climate change into curriculum development. So working really within the processes that we already have to incorporate some climate change thinking. And five major areas where we can start to incorporate that climate change thinking is in our emergency response planning, public health, infrastructure, ecosystems, and education. So I'll go through some specific adaptation strategies for each of these. So for instance, in the transportation and road sector, a couple of measures that can be taken are to install permanent remotely activated warning signs that can free up personnel to focus on higher priority actions during an extreme weather event. Many areas in our region have only one access road. So another strategy is to consider adding an emergency or secondary access road, and these type of actions can be incorporated into development regulations. In the environment and human health area, there are a lot of benefits. We tend to use best management practices for promoting environmental health anyway that also help us to deal with climate change. So we improve conditions of our aquatic habitats. We increase the reliability and economics of water supplies, using our resources more effectively. Providing land use planning really helps to reduce urban sprawl, which doesn't only reduce emissions from driving, but also reduces habitat destruction, fragmentation, and the amount of paving. So a lot of cascading benefits from some of these adaptation strategies. In the energy sector, there's a lot of things we can do to increase our energy efficiency, protecting our facilities against extreme weather events, diversifying our power supply in the event of power plant failures due to excess demand created by extreme heat or by extreme weather events. So lots of things in the energy sector to adapt to changing climate. And then infrastructure adjustments. This is really big in our area, looking at the life of our infrastructure and incorporating that into our planning to ensure that our infrastructure is able to function under a generally more variable climate, especially under drier summer and wetter winter conditions. Ecosystem planning is really helpful for addressing climate change impacts. protecting and enhancing migration corridors to allow species to migrate as the climate changes, and identifying management practices that will ensure the successful attainment of conservation and management goals is extremely important. As well as there are a lot of projects in this area looking at the rehabilitation of riparian and floodplain forests to help shade and thus cool streams, which help to reduce flooding and provide recreational opportunities. It also reduces the stress on our native fish populations. And then finally, education. This is really where the Sea Grant program fits in as well, really helping our coastal communities to understand the changes that are occurring around us and to take that knowledge into account in individual actions and daily life and in planning for the long term. So again, there are a lot of benefits for adaptation, not only in addressing climate change, but in general planning and development of our communities. So I just have to always include this picture of the Canadians adapt. I lived in Canada for a couple years and just for some reason can't picture it with palm trees or anything, so I always have to add that picture. Now I just want to talk a little bit about a specific tool. One other thing that communities have really started to do in this area is to assess their particular vulnerability to climate change. So I'm going to talk a little bit about this tool that Minnesota Sea Grant has been using throughout the region. So the question really came up, what do these changes and impacts mean for our communities? When for the past decades we've been planning, making decisions, and building our infrastructure based on a relatively stable climate. So this question led to the creation of a tool called a self-assessment to address climate change readiness in your Great Lakes community. This tool was developed by Diane Desautels, who was my predecessor at Minnesota Sea Grant, in partnership with the Sea Grant Network climate educators in Michigan, Illinois, Indiana, and Wisconsin. This is based on a document out of Mississippi, Alabama Sea Grant called the Coastal Community Resiliency Index. And the purpose is to provide community leaders, administrators, planners, engineers, public work directors, and natural resource managers with a simple and inexpensive method to review potential vulnerabilities to climate trends and to bring climate adaptation thinking into planning and preparedness on the community level. As well as this helps to identify that low-hanging fruit or specific vulnerabilities in each community that may need further attention. So the main goal is to help communities make decisions today that will prepare them for the changing conditions into the future, to be more sustainable and resilient. So this is done through education, planning, and incorporation of climate adaptation strategies into policies that can help reduce the impacts and costs of climate change into infrastructure, natural resources, economies, and social well-being. So this tool is not meant to be a complete vulnerability assessment, but rather a jumping off point. And it's made up of a simple checklist to help identify, again, that low-hanging fruit or specific areas for each community to focus on. So it's broken down into the 9 categories that you can see listed on the right here. And I'll show just a little bit of a snapshot of what that looks like. So the idea is to have a community work together so that each participant can complete the area that they feel comfortable with on an individual basis or as a group, depending on however that community likes to work. So this kind of shows an example of the critical infrastructure and flood readiness category. So this would be filled out, is the sewage treatment system located within the floodplain? Based on these 3 scenarios listed. So to kind of gauge where that community currently is with their infrastructure and flooding readiness. Here's another example looking at the water resources category. So looking at the issues of invasive species, looking at impacts from a wildfire, all of these things to, again, really narrow down that focus. And these answers are all made up, but this is what the end of the assessment may look like. So you can kind of see where this community would have ranked on the climate readiness scale. So for example, in built infrastructure and environment, or built environment and infrastructure, they have a pretty low readiness. So that would be an area where you could go in and do a more in-depth vulnerability assessment and identify where some green infrastructure or where some options might be to help make this community more ready for flooding. Another category that would rank low could be ecosystems and habitats. So looking at things to help better prepare the ecosystems and habitats in that area for a changing climate. So after that review, or after this tool is used in a community, the next steps may be to review where those particular vulnerabilities were, and then to provide some suggestions and to provide some resources over the coming months for that community to consider. And then as well as to work with that community to implement some of these decisions, as well as to find funding. And it's really important to learn throughout our region, throughout the nation, but especially in the Great Lakes region, to collaborate with other communities to share resources, ideas, case studies on planning and projects that have been used. And at the bottom here you see two logos. These are both vulnerability assessment tools that are freely available and again can provide a next step after assessing, after having that initial discussion about climate change readiness. So that's where I'll end it, and I can take any questions at this time. My contact information is here if you'd like to follow up with me about anything, or if you have any additional questions. I'd be happy to provide any further information or resources that I used today, and thank you very much for participating.
Okay, great. Thank you, Hilarie. It doesn't look like we have any questions that people have submitted throughout the webinar, so I guess we can end it there. Thank you so much for presenting, and thank you to everyone for attending.
Thank you very much.